So we are MaidSafe. My name's Nick Lambert, and with me is David, who's the founder and CEO. So as you can tell from our slightly funny accents, we are not from around here. So we are from all the way from Scotland, and we must be the world's oldest startup. So we've been going for about 8 years now, and our team of 14 have pulled together a platform that we think is quite special. And we're going to try and take you through that today. So MaidSafe have really set out to try and change the world. There's no doubt about that. It's a fully decentralized computing platform which will enable the re-implementation of all the internet services that we currently have today, by getting rid of all data centers and all servers. So because we're at a Bitcoin conference, it seems fitting to try and tie in what we are doing to Bitcoin. So we think that MaidSafe is for data what Bitcoin is for trade. So in the way today that Bitcoin removes financial services, companies and banks, and allows us to make cheap transactions, MaidSafe is doing that same thing for data. We are removing large technology companies and data centers, people that mine your data and give you crappy adverts you don't want to see, on the basis that you're actually getting a service for free, which we all know is not the case. So MaidSafe is doing for data what Bitcoin is doing for trade. So that's what we're all about. I'm going to ask a man over there to start like a 5-minute video, and this should help explain the concept quite well. So I hope you enjoy it.
Why are today's systems so vulnerable and unreliable? Because today our internet consists of servers and connected computers, in which the files are normally stored in one place as complete files readable by anyone. If the walls of system security are penetrated, the data is ripe for the picking, even if the data has been encrypted. If it is all in one computer, a single provider, or a local network, it can still be stolen or erased. Today's data is not physically secured from any third parties. There is always somebody who can delete, corrupt, or snoop on you, until now. In the MaidSafe system, data is never vulnerable. As soon as a document is saved, remarkable things happen. The data is automatically shredded and encrypted by a unique algorithm that uses the data itself to create the encryption keys required for the very high levels of encryption. This data is then distributed intelligently to the network. This network spans the planet. All of this thoroughly encrypted code now resides in several time zones, securely stored in multiple copies in locked space on other networked computers, using a portion of whatever unused hard drive space is available, as if the data was transformed into a grain of sand and distributed wherever the wind takes it, far away from prying eyes. And your secure login has been achieved by a phenomenal new system called Anonymous, or self-authentication. This is a system where you decide to join a network and the choice is 100% yours. You give up some unused space on your computer and that is your payment. Nothing else is required. The deal is between you as a person and the network. You are in complete control of your own destiny and required to ask nobody for any permission. Only now can you be secure. No third party was involved. Just you, the machine, and the software. And at no time was your password transmitted on the network in any form whatsoever. To the world, you are completely anonymous, safe, and free. Now, your digital work and data reside not on vulnerable hard drives that could fail, be offline, corrupted, stolen, or spied upon, but on a huge distributed anonymous network with state-of-the-art protection of both data and privacy. You will never lose your data again. There is no backup or sync required. Everything just works and is available only when you want it. So, what do we do with all that free space now that we have computers all over the world with more space than they need? Some of this space is used to store the network chunks. This mishmash of electronic bits is stored everywhere on every hard drive. Your computer fuels the network that you are now part of. Rather than slowing down with more data, as traditional client-server models do, this network increases in speed and performance as more people use it. In this network, denial of service and similar cyber attacks are thwarted and useless. Popular websites simply go faster rather than crashing. There is a reason this is called logical. After 7 years of testing, innovating, and lots of effort, they have released all code, papers, patents, and algorithms to the world. MaidSafe has met universities and attended many events to explain their proposals and answer questions, as well as publishing papers and trialling much of the code in one of the world's largest organizations, all with very positive results. All of MaidSafe's patents have been made available worldwide to allow developers to use a truly global platform to create next-generation software products such as data that increases in speed as more people use it due to intelligent caching, which makes popular data faster and also prevents many cyber attacks and cyber terrorism. People will share privately, freely, and instantly. Doctors will save more lives by sharing medical research in real time. And groups of common interest can get together and share experiences and information instantly and safely. With real sharing, we will defeat many global issues by simply combining our efforts and publishing our feelings and thoughts instantly and securely. Whistleblowers and victims of oppression will share their findings safely and free from persecution. Secure messaging in the form of email, video, and voice are inherent in the network design. Nobody can trace or eavesdrop on any of your communications anymore. What you say now is private. Anyone can use the code and patents to build these powerful new products and services at no cost and without fear of the service ever being compromised or stopped. This is a network of equals, and ownership belongs to all users all of the time. All developers have free access to an open API and can start creating and deploying amazing ideas and innovations that could change the world right now. Now, what are you prepared to do?
Well, that's that video. So, thanks for watching that. It's quite disingenuous, the video. Some people think that MaidSafe is just one huge Dropbox or something like that. It's far, far from it. You can consider the network as two separate things. There's a vault process which runs, that's the item that gives up disk space and adds the computer to the network. And then there's a client process, which is it's almost like your web browser, if you like, your access. But it's a different web browser. It's a web browser that gives you access to the disk API, and that's for structured and unstructured data and communications. So our approach from day one has been, why don't we take all the resources that's available in all the computers in all the world and put them together and forget this server model? Why would we speak to someone? If I'm going to send a message to you, why would I send it through Google? It's none of their business what I'm going to say to you. I wasn't going to send you a message, but just in case. In designing this system as well, we really looked at how natural systems work, how nature works, like ant colonies and all the rest of it. And the server model is a very unnatural model. It's not found anywhere in nature. In nature, something like an ant colony is a very complex society. It's very sophisticated. They've worked for 150 million years. Our servers have worked for about 20 and they don't work. We're always getting hacked. We're getting passwords lost. We're giving away valuable information the whole time. Now, water probably is the most valuable commodity in the world, I think, closely followed by information and data. And as we go along now, you can see people starting to leave some information on Google. You forget what things are, you just Google them, or you leave information on your phone, you forget people's phone numbers, just look up their name. Data and data networks are becoming much more valuable to humans. And as we go along, we're going to keep allowing networks to have more information about us. So the MaidSafe proposition is that network should be our network, and it should belong to no one. That should be the network should be like one large machine that we completely trust. And the reason that we should completely trust it is the same reason that we should trust Bitcoin, because the network's defined and managed by maths and maths alone. So people using the MaidSafe network, one of the unique things about it and the strange monetization things in the old world, pre-Bitcoin world, was that we can't stop the network once we release it. It's all open source, but the actual network is like a live thing. It keeps connecting to other nodes. It won't take orders from us. If we try and upgrade the software with a version of the network that works, it will only accept upgrades that are equal to or better than its current performance. It'll actually refuse. It's a self-QA system, which sounds quite bizarre, but that's what it does. So the system itself, you can imagine, we basically take all these computers, connect them all together and turn it into one great big machine. And that machine's internals are available to all of us. Because of that, and for us to be able to say to you, we can provide you security, privacy and freedom, that's quite a big statement. It's our vision. And the way that we provide security to you is, for a start, we don't know who you are. We don't know what you're called. We don't know where your data went. So nobody can come to MaidSafe or anybody that's on this network and ask for data to be deleted because we don't know where it is. That allows you to have something that we've never had before in the internet or the internet services world, which is, there's debates. People say that they have logical security. Google might say they encrypt something, or Dropbox might say they encrypt. Nobody gives anybody physical security. MaidSafe provides physical security because we can't touch your data. We can't delete your data. We can't corrupt your data. The network won't allow it. So pre-Bitcoin business models, that's quite an interesting one, because when you say to VCs, we don't know our customers, we'll never know our customers, we can't do anything to our customers, we can't send them messages, we can't give them adverts, how do you monetize something like that? That was always a fight for us. So how do you monetize something? You've got to be able to survive, you've got to be able to pay your family and food and everything like that. Bitcoin coming about was a revelation because it allowed us to say to people, this is what decentralization can do for trade. Now, it's time we did the same for data. Data is arguably as important or more important than just a trading mechanism. So we're actually in the process of implementing a token-based system. That token-based system is actually pretty interesting because if you imagine the computers that are making the network up, storing pieces of data, they don't know what they're storing. It's just chunks of extremely encrypted information, very small parts of files, so nobody's storing a file. The network can't decrypt a file, but all of these machines are basically mining. They're storing information, and this is what we've come up with as a sort of pre-announcement, as a proof of resource, a bit like Bitcoin's proof of work. The difference being, as a machine's storing data and it stores past what the network requires, it can start earning coins, space coins we're calling them just now. They won't be called that when we release it. These space coins, so when someone goes to use the system, maybe they've only got a mobile phone, they don't have a computer that's going to be able to pay for the resource. So they can buy one of these tokens. But they buy one of these tokens from a network that's owned by all of us. So there's no man in it. Like Bitcoin, we remove all the man in the middle stuff, we remove all the skimming 1% off this transaction. So these miners will mine a resource. The proof of that resource can be purchased by people, and they can then access the network and store all the data on it. The beauty of that is the resource that's actually being mined is immediately valuable. We're not burning 1 watt of electricity here for something that's not going to get used. We're actually mining space that we need to put our data on, and we have to be able to put that data on anonymously. So over the next few weeks, we'll be finalising that token system, but it's pretty neat because what it means is if you actually provide a gigabyte of space, say, The network will probably give you back 3-4 gigabytes that you can store on. That's for life. You'll have that for life. If somebody buys a terabyte of space on this network, and they'll be buying the terabyte from you guys, not from me or whatever, they'll have that for life, because the miners have to mine over and above the data that already exists. So as a society and a species, what we can do is we can hold on to all the data that's ever made public, keep that data, and make sure that these miners are mining past that data space that provides a system that means we can store data, share data, put transactions on. There's a n-dimensional blockchain on the MaidSafe network as well. That's where the tokens are going. That's where hopefully Bitcoin's blockchain will go. Fully distributed is the way forward. We'll be able to communicate, do everything you can do in the current internet, but in a completely decentralized fashion, paid for by us, for us. And that's really the MaidSafe proposition. So I'm going to leave it there, because I know there's going to be quite a lot of I hope there's going to be quite a lot of questions, because it sounds a bit too good to be true at times. So.
How do I get set up with it?
If you go to maidsafe.net, the API at the moment is just being finalised, so we're signing up developers. So the way that we are going to market is we're saying we'll provide the platform and developers will come, and so we've got a couple of guys doing a Dropbox type thing, which is obvious, Facebook, Open Science, various things. So if you go to the MaidSafe site and then look for the developer list, sign up for that, and you'll be writing a button for getting early access. We hope to have example applications by New York next month.
Great, thanks.
No problem, thank you.
So I have tens of mining machines that are mining scripts, so they're just regular motherboard, GPU,
Yeah.
processor running about 2% load. If I wanted to contribute to your network, it would cost me next to nothing to, stick several terabyte drives on these computers, and they're
Yeah.
online all the time, and they're running. And so, what would that look like, especially if I was providing far more than I needed as far as storage space for myself?
That's the proof of resource system. So what actually happens there? You put the machines on to the network. They're going to provide resources to the network. From your client machine, from the client that you have, you basically, what happens underneath is you get the private key from each of these nodes that you put on, and you can sign a proof of resource. The network then checks that resource, and when these machines have stored more than you're storing, the machines start earning tokens. The good thing about it is ASIC resistant, so everybody with a machine can mine for this data, or mine for these tokens. The tokens are distributed absolutely randomly across the network. So as soon as you put machines on, pardon?
Just like Bitcoin mining?
It's very like Bitcoin mining. The large difference is that what you do to mine is add value to the network, and the network sees that value and provides a token to you.
But in a random nature, like
Yeah.
Bitcoin.
Yeah, absolutely. It's when you have mined more space than the network requires, it's a sort of blind lottery.
Right.
So you request a space in the blockchain, and if that space is empty, you get a token.
So it's pretty much directly analogous, because
Yeah, absolutely.
if you're providing hashing resources to the network for transactions with Bitcoin, whereas you're providing a storage resource for your network for storage.
Yeah.
And so it'll be continuously randomly giving out outputs.
Yeah.
So the longer you keep it online, the more you... Okay, that's awesome.
Yeah, you'll learn as long as you keep a node online, even if it fills up, it'll still earn tokens. Even if it's not able to store anymore, the fact that it's holding stored data, it will be able to earn tokens.
And these tokens will be freely traded probably on
Yeah.
exchanges and... Okay.
And the great thing is if you start early, right at the start, obviously you get a much higher chance of winning the lottery, so start early.
I'll go on eBay and buy some hardware.
So does this system only store data, or does it allow for like arbitrary code execution? So if I'm writing an application, like I write in sometimes I'm using Node and sometimes in Haskell or whatever, can it run both systems, or do I have to use like C++ native or something to do it?
No, it can run anything basically. In terms of sharing data, it shares at the file system level, so you can share a running CAD program with someone else or whatever. Internally in the network, if you think of the network a bit like Hadoop and Cassandra, so it's structured and unstructured data management, so you've got a full key value NoSQL database running the whole time with transaction managers, so you can run fully dynamic applications.
Okay.
Thank you.
Thank you. With respect to data storage and storing all these little encrypted chunks across the entire network, how is data redundancy handled? And where is the metadata for assembling all those data chunks back together? If not centralized, how does that work?
Yeah, excuse me, that's in the client part of the system. It's quite a long explanation. Usually it's about a 4-hour presentation to do that, but when the files all self-encrypt, you go through a self-encryption process, which is like convergent encryption, but multiple convergent encryption using a chunking thing. So everybody that puts a file on the system, it'll be the same chunks it's created. So the resultant of this self-encryption process is a very small key to that data. And so each file would make up a directory. Then the directory is another small key because it's encrypted as well. So when you log in, you actually get the key to your root directory, plus all the ability to recover your root directory. Then as you click on any subdirectory, it goes and recovers that for you. So the metadata is not known by the network. It's only known by the person using it. And interestingly, that means when you log in, the data appears on a virtual drive. So it's in memory. It never touches a hard drive. When you log back out, there's zero trace that you've used that computer.
What about redundancy?
Redundancy, there's four live copies of the data and up to 16 dead copies of the data. So there's a vault paper that explains that more, but each node has got about 14 personas. So one of the personas is a data manager. 4 data managers closest to the address of the data watch all of the locations it's storing that data. We had to rewrite DHT technology plus a UDP layer, reliable UDP. So within 20 milliseconds, the network can tell if a piece of data has gone off. That information goes to data managers and they'll decide, do I need to make another copy or not? So it's pretty wicked.
But you have a threshold for some.
Pardon?
So you're talking that your speed goes up as you distribute, right?
Yeah.
But if I give you a chunk of data and I want to maintain some speed, how do you determine the threshold of distribution to maintain that speed?
In terms of speed, how that works is opportunistic caching. So it's a bit like Squid proxy server type thing. You're looking for a piece of data that will have a particular hash value. The network, the DHT is recursive, which is an interesting thing because on the first hop, the very first transmission of any information in the network, the IP address is scrubbed and you're onto the overlay side. So it's almost like you've done a Tor thing immediately. And as you get that data, it's copied into a FIFO register in every node towards you. If someone next to you tries to get the same piece of data, they'll pick it up earlier out of the FIFOs, out of RAM. If someone else, then so you can imagine it's almost like the network breathes all the data out, says it's required here, so it has to go faster. So it surrounds that person. It's an XOR-based address scheme. So it surrounds the part of the network that's reading the data. And that data is read at network speed out of memory, which we've found is significantly faster than reading it off your local hard drive. So it's pretty nice.
So some of the language that I've heard as far as, it's your choice whether you join a network, but you keep on talking about the network. I'm assuming that multiple networks can and will be set up. So maybe there's one that's like, well, this is my company's network, and so we want to just put all our stuff on this network, and it's not really accessible to anyone else.
Yeah.
Is that the case? And is there, I mean, I'm assuming that coins will be generated on each individual network, and are they transferable between, I'm assuming they're not transferable between networks.
No.
Can you speak to that? I guess?
Yeah. You can actually create separate networks, but excuse me, what actually happens is, we spoke to the MOD about this in the UK and several banks, and the health service, the National Health Service. Interestingly, companies have this approach with today's centralised network where they keep all their data secure behind bomb shelters and machine gun things and VPNs and routers and all the rest of it. Because it's whole files that they're keeping, and they're maybe encrypted whole files, but they're generally rubbish systems with password lists on them. And a MaidSafe network, the data distributes quite widely, and it's all these chunks. The bigger the pool of chunks, the harder it is to detect which chunk belongs to which file. So it actually becomes more secure to put the data on the public internet. So companies with really high security in this decentralized network should distribute their data widely. If they try and keep their data in a silo, then it would still be inordinately difficult to decrypt it, but it's a smaller set, so that the attack vector is much simpler to decrypt it. Also, the networks, it's a bit like the network effect of Bitcoin. You know, you can create all these separate altcoins and stuff, but as the network grows, and hopefully MaidSafe or whatever gets this network effect, more and more people using it, it actually goes faster. And it becomes more reliable. So someone else could set up another network for another purpose, maybe to do CPU mining. But inbuilt into MaidSafe network blockchain, there's we're speaking to Tor guys, you can do proof of bandwidth, somebody else could do proof of CPU. So we're very intent in not owning this network. We keep calling it MaidSafe network, and I wish there was another name for it. But
hi, my question was about fees. So I think you mentioned that there were no fees. So for submission to the network, like you don't have to pay in tokens to do so. How do you deal with something like a denial of service attack relating to spam?
The denial of service attack, two different ones. The network part of the system, the vaults, the thing that creates the resource, denial of service attacks are inordinately difficult because of the opportunistic caching. As soon as you ask for data, it comes very close to you. So if you ask for it again, it's on your machine. So you end up denying yourself, which is quite a kind of interesting way to look at it. The other way to look at that is, in today's networks, if you have a very popular website, it crashes. In a MaidSafe network, if it's very popular, it goes faster. So logic wins the day. In terms of spam, on the human side of the network, then that's basically reputation systems that we're playing with there. So you can whitelist, it's like the email system, you can whitelist or blacklist, but you can actually add reputation. So if you add me as a contact and I send you a spam thing, you say it's spam, a bit like what Google does. And if enough people say that I've spam, then my reputation starts going down. And then you could say, I don't want to connect to anyone with a reputation less than 50% because they're likely to be spammers. So we're still playing with those algorithms because one thing that we can't quite grasp is minority protection. You know, but these are things that we're doing that in the open. So hopefully everybody helps. Thank you.
Just occurred to me, have you guys thought about implications for secure communication over this network? Because obviously if you shared your private key with, say, a friend, you guys could transmit messages between each other across the world, or files or whatever.
Yeah.
According to what you're saying, pretty much anonymously, securely.
Yeah. Secure communication is one of the first examples that we're doing. So before New York happens, we should have the system running. And the biggest problem with MaidSafe just now, if you go to the site and look at the code, you just get swamped because there's hundreds, there's 14 libraries with all sorts of things. Before New York, we'll have a big Start Here button, and that'll take developers through examples. And one of the first examples is secure messaging. An interesting thing with secure messaging, because of this data map process, we can actually transmit to someone a terabyte hard drive, and you get it in like a few milliseconds. And that'll be on your computer,
Right.
virtually on your computer.
Right. Okay. Thanks.
Thank you.
Hello.
Hello.
How soon can a simple-minded user like me begin to use and contribute resources to the MaidSafe network?
By New York, you will be able to just download and click in. The other thing that we've done is we've focused very much on the consumer, because a lot of decentralized apps focus very much on the early adopter market. You know, you must run Linux, set up a diaspora server, and, you know, do somersaults. By New York, you will be able to just download a vault and run it, and that will be accumulating tokens and providing stuff for the network. We're hoping that some of the third-party developers that's on our mailing list now will have some apps starting to come out by then as well. So in the next month, you should be able to mine, if you like, provide space to the network. And if we can actually put out apps ourselves, but we really don't want to. We really want to just be the platform. But next month or 6 weeks, I would say you should be able to get some apps there. Messaging in Dropbox will be the first.
When you said New York, are you making a presentation in New York?
Yeah, we will be.
Okay, cool.
Pardon?
It's the 7th thing. This is the Bitcoin conference in New York, so it's like the 7th and 8th of April, I think.
Follow on to my previous question. Is the client a single point of failure, or can you back it up? Because that's where the metadata is.
The client actually doesn't hold anything. Everything gets stored onto the network.
Including the metadata?
Including the metadata, yeah. The metadata goes through this encryption process. It leaves you with a small initial piece of metadata, which is encrypted and stored onto the network when you leave the computer. So when you go back, you type in a couple of pieces of information that allows the network to retrieve the encrypted metadata to you. And then you decrypt that locally.
And are those just credentials or something that
Yeah,
you
they're just
provide?
credentials.
Okay.
It's 2 passwords.
Gotcha. Wow.
We can use biometrics as well because we don't transmit the password, so that the data comes to you. If anybody's trying to hack the network, it will give them what looks like a login token every single time. It'll just take them 149 trillion years to decrypt it, but it's rubbish. But because we don't send the password, you can actually use biometrics.
Very cool. Thank you.
Thank you. Brilliant. Okay. Thanks very much for your time.
Thanks,
Appreciate
everyone.
it.